take it away, Matt. Cheers.
Thank you. All right, good morning, everybody. Thank you for that introduction. So yes, I'm Matt. I am the tech lead of the customer reliability engineering team at Google. I'd love to spend all of my time telling you about what customer reliability engineering is and what we do, but I've only got sort of 15 minutes today. So if you're interested in hearing more about customer reliability engineering, this presentation is where I want to direct you. But very briefly, you might have heard of SRE, or Site Reliability Engineering. Site Reliability Engineering is Google's implementation of the DevOps principles. So it's a set of practices and a set of things that we've found work very well for running Google services. And customer reliability engineering is taking those principles and those practices and helping our customers who are coming onto the cloud platform make it real, essentially doing SRE across a provider-customer boundary instead of just within the company. So I work from Cambridge, a couple of hours down the road. Very exciting for me to be here talking to a local audience rather than most of my day I sit in front of a Google Hangout on a screen talking to people in the US or in Europe or somewhere. So great to be here. I'd love to chat to many of you afterwards, morning tea, lunch after today. My little secret is I don't really have a serverless background. Google as a company has done a lot with serverless, right from App Engine or the way we deploy software at Google is it gets packaged up into a container and then it goes on to our container runtime environment called Borg, which is kind of Kubernetes is an example of that externally. So there's a lot of serverless in Google's history, but I come from an infrastructure, I come from a networking background. Prior to my current role working from home, I led the SRE teams in London that were responsible for all of the front-end networking, GCP and App Engine components. So think, reverse proxies, DNS, Compute Engine, App Engine. So I have some exposure to serverless, but I don't write serverless code on a day-to-day basis. But in my role with CRE, I get to talk to a lot of customers, and they say, Google has experience in SRE, Google has done serverless. What is the serverless thing? Tell me about it. How do I apply SRE, or how do I apply DevOps? How do I apply any of these concepts that I'm hearing about in the media to my problems today? And inevitably, they point me to news articles with headlines like, serverless is super ops, or serverless is maybe the death of DevOps, or serverless takes DevOps to the next level. And so what do we believe here? And I mean, I'm not here today to explain any of these to you. And fundamentally, I think each of these articles, has a kernel of truth to it. But at the end of the day, as this conference is based around, and as Jeff said, or as Paul said, serverless is just a name. We could have called it Jeff. But I think there is a kernel of truth underlying all of this. What all of us are trying to understand is what should we focus on? Where should we spend our time? As a developer or an operator or anybody working in this space, what we want to know is, what is going to help me achieve my goals most easily? And there's a lot of competing goals on our time today. We are looking for high velocity. We're looking to deliver features that make our users happy. We're looking for reliability. And so how do we bring all of these things together? And how do we find the right balance? And I think that's sort of what these articles and what all these discussions around serverless is X or serverless is Y are really getting at. So in my experience, the claim I want to make today and what I want to talk to you about is the number one feature of any product is its reliability. You can be developing, you can have as much velocity as you can achieve, you can deliver as many features as is humanly possible or inhumanly possible, in some cases. But at the end of the day, what matters is whether your users can trust that those features, that application is going to be there when they want to use it. And if your users do not have that trust in your application, then everything that you are developing, everything that you're deploying is essentially for nothing, because those users are eventually going to go and find a different application. They're going to move to a different provider. And so that's a really core concept for us, and it's something that in CRE we spend a lot of time working with our customers on, is it comes down to trust. Reliability is the number one feature of any piece of software, and reliability essentially means user trust. So I want to just dig into that a little bit, and I want you to think about the users of this system. Sitting in that space shuttle, up and looking out those tiny windows, think about the amount of trust that the users of that system have to have in the development process and everything that's gone into that. There's immense amounts of trust there. Similarly, I want you to think about the users of a mobile game, something that's probably much closer to the types of problems that we are all solving on a day-to-day basis. There's trust involved here as well, right? If users of mobile games, users of our applications, care about their reliability. They care about them being there when they want them to be. So there's still trust. There's still an expectation of reliability. But a brief outage of a mobile game, a brief outage of one of our web-based systems, as long as it's not common, as long as it's not repeated, is unlikely to impact the trust in the system in the same way that even a very brief outage or fault in a high availability system like the space shuttle would be. So this concept of trust is first of all fundamental to what we're trying to achieve with our users. We need them to trust our software. We need them to find it reliable. But that trust is very context dependent. It means a different thing for a financial system, to a game system, to a free system. So you've got to find what does trust mean for your business. And then the next problem is that even if you believe me that trust is what you're looking for in your software and in your systems, trust is really hard to measure. Maybe, does anybody out here have psychology training, or has anybody here got, all right, great, so I'd love to chat with you afterwards, and maybe we can share some ideas about how on earth do I go about measuring trust. But I think even if you have a wonderful solution for me, the question is, how do I then measure it in real time? How do I tell on a day-by-day, minute-by-minute, second-by-second basis whether my software is keeping your trust or whether my software is losing your trust? And so that's an opportunity for us as engineers to now apply some technical knowledge to this problem space. So Google put out a book a couple of years ago on site reliability engineering. Basically, here's what we've found works internally for us. And one of the key concepts in that book was of a service level indicator. And so this is how we go about quantifying trust. So it's defined as a carefully defined quantitative measure of some aspect of the level of service that's provided. And so the example that we have on the screen here is the HTTP error rate. So take all of the response codes coming back from your application, take those that are errors, 500s, divide them by the total rate of requests, and you get a ratio. And that shows you how your application's doing. But now you have the question, you see some spikes there earlier in the day. Are those spikes a problem? Are those spikes to a level where they are eroding trust in my service of my users? And so the next concept that we need to move on to is the service level objective. And that's a target value or a range of values for that quantifiable metric, the service level indicator, that tell you whether that indicator is currently in a state that is going to be retaining and hopefully even gaining users' trust in your service, or whether that indicator is at a point where users are going to be unhappy, they're going to be losing trust in your service. And so in this case, here's where we need to dig into what is my application doing and how are my users interacting with it. Let's say, so we have this HTTP error rate. Let's say it's for a browser-based application which a user is interacting with directly. The error rate that you're willing to tolerate there is going to be very different to an HTTP service which is serving as the back end for a mobile application which has the ability to retry under the hood and whether a certain low rate of errors before that actually becomes visible to the user. And so, if you're in that situation, you're running a mobile background, a 0.1% or a 1% rate of errors from your API might be something that's entirely fine. And so you can set your objective at that level. Whereas if you're serving an interactive service, you know that to retain your users' trust, you actually need to target a higher level of availability. So we'll come back to making that real in a second. But I also wanted to touch on the concept of a service level agreement, which is perhaps the more common acronym that a lot of people hear about. But it's actually one that we as SREs and as engineers deal with the least, because it's more of a business level thing. Service level agreement is the consequences. It's the business agreement, often a legal agreement, for what happens if you fail to meet that service level agreement. So quick recap. SLI, service level indicator, quantifiable metric, some aspect of your service that you've very carefully chosen to be the thing that is the proxy for user trust. Service level objective is a goal for that indicator, and then an agreement, service level agreement, is that goal plus a set of penalties that you've agreed to if you fail to meet the goal. The next concept I want to bring to you, and this is where it starts to get more applied, and this is how I hope to show you, how this can help improve your lives as developers and operators, product managers, whatever role you're fulfilling on a day-to-day basis, is SLOs are great. It's all about uptime, like what's the level of reliability that you need from your service. But often it's actually easier to switch that round and think about the inverse. So you can take 1 minus the SLO, and that gives you an error budget. And this, at least to me, is a much more easy concept to reason about. I have a budget. How do I want to spend that budget? That's something that I can actually use in the operations of my system. And so there's some examples there, but more easily comprehensible is if we put this in terms of actual time periods. So if you're running a system and you've decided that your SLO, your objective, is 3 nines of availability, that means that in 30 days, you can afford for that system to not be functioning to that objective for 43.2 minutes. And you can see the times decrease as you improve the reliability. And then, if you're going for 5 nines of reliability, over a year, you've got just 5 minutes of error budget that you have to spend. So what's the point of this error budget? Like, what should you use it for? The first thing that I think it is useful for is as a planning tool. How many of you have been in the situation where somebody's come to you and said, please write me a piece of software, and they've listed out all the functional requirements for you, and then you might turn around to them and say, what's the availability requirement? How critical is this piece of software? And a common answer is, 100%. Has to be always available. Has anybody been in that situation ever? Yeah, sure. And so the SLO and the error budget gives you a tool that you can have a conversation to bring back from that. Like 100% is just the wrong target for any software application, I'm going to claim. Hopefully it's not a controversial statement to say that the higher your reliability target, the larger the percentage of your engineering time is going to be spent on reliability features rather than product features or things that actually deliver functional benefit to the user. And so every application will have a different point on that curve where they've got to target. But if you're targeting 5 nines or 100% reliability, then most of your development effort is going to be going on into the infrastructure and how you achieve that rather than actually delivering the functions to your users. And so putting the conversation in these terms can help to talk about, to say, 4 nines, that means we've got a much smaller error budget than if we target 3 nines, and therefore we're going to have to do this set of development on our reliability features, which means that these set of functional features that you want aren't going to come anytime soon. The next more real-time way that you can use it is as a feedback method. So let's say you've chosen what your objective is, you've used that to set your development budget, you've got something out there, you've got users using it, and now you're really wanting to monitor on a day-to-day basis, am I retaining that trust or am I burning that trust? And so you monitor this, and it's a check on your development velocity versus your reliability. If at the end of the month, or if you're looking at it on a rolling 30-day window, you see that you're spending more than your budget, then that's a signal to you that you need to slow down and you need to invest more in the reliability of your software. Perhaps you should be spending more time writing more tests or increasing the coverage of your integration testing environment. Maybe it's re-architecting a component of your system, so that it is more error resilient, that it can hide errors from the user, that it's more graceful failure. There's a huge range of things that you could do, but if you're spending your budget, it's a signal to you that that's where you should invest your time and effort. On the other hand, the state that we'd all like to be in is you get to the end of the period and you see that, hey, things are going great. I've got all of this budget here that I didn't spend. My service was more reliable than we said it needed to be. And that's also a problem because it means that you're not taking advantage of that budget to actually deliver features and move your service along. And so in that case, you might want to make the decision that, we should move a little bit faster here. We should take a little bit more risk. We should try and increase our development velocity, get features out faster, maybe be a bit more ambitious about that thing that we were a little bit nervous about developing. Let's give it a try. Let's release it to a few % of users and see how it goes. So that constant feedback from the error budget as to how are your users being served, how should I invest my development time as a result, is another way to use the budget. And then finally, it's just a common vocabulary to link roles. Whatever labels we're applying to ourselves, whether we're a developer, an operator, DevOps, there's product manager, executive. There's a number of different people, a number of different roles that are involved in delivering software today. And often we all come at it from different perspectives. We all have different needs. But if we can all centralize around the error budget as the way to orient our thinking and orient our planning back on what the users of our system needs, then that gives us a common terminology. It gives us a common frame of reference that we can have much more objective discussions around, rather than, I feel like this feature is going to be too risky to launch, or I feel like this feature needs double the testing. So the key thing that we're all trying to achieve is high velocity, high release of features with high reliability. And so what that means in this term is that the bulk of your error budget is spent on planned activities. It's spent on getting those new features out to production. It's spent on experiments. It's not spent on unexpected failure or things that crop up unexpectedly. So essentially, this is risk management, right? There's a set of risks that our applications, our microservices, our Lambda functions, however we've architected our application, there's a set of things out there that are waiting to take us down and cause us problems. And so we need to catalog those things, and we need to estimate their size in terms of their likelihood and their impact, or their time to failure. How often, have I got 5 days before this thing is likely to occur, or is this going to occur once a year or once every 2 years? And then how long does it take me to restore when that thing happens? And that can give us an estimated cost for that risk. And then we can stack rank them and, again, prioritize our effort in terms of what should we be investing in mitigating and what can we just ignore because it's not going to impact our error budget. And if we think about our systems in this way, and if we think about our approach as risk managers, then that can allow us to maximize our budget to spend on developing features and releasing features. And I guess the bit that I missed out there was, like, in my experience and in Google's experience, releasing features and changing your system is the #1 cause of error budget burn. If I had to pick a time of the year when I would be on call for a system that I didn't know well and I was going to have to debug, it would be Christmas, New Year, the holiday period when everybody's away from their desk and nobody's actually changing the system, because I can virtually guarantee you that it's going to run a lot more stably during that time of the year than sometime in the middle of winter when everybody's at their desks, frantically banging out new code and deploying it. And so that's sort of the background for why we say we want to keep most of our error budget for those change-introducing opportunities, which we know are going to burn more of the budget. And so we want to risk manage away all of the surprise spend. I have a whole 40-minute talk on that, which, if any of you want to hear that, NZ282 is leaving Auckland 11 o'clock tonight to take me up to Singapore to deliver that at SRECon tomorrow. Still seats available. Come along, you only live once. If that's not an option for you, then again, the link here is to a recording of the talk that I gave at SRECon, the Americas edition, back in March. So here's the key takeaways. Like, the users are first. Reliability is the #1 feature. That's far more important than any discussion of what is serverless, is it DevOps, is it NoOps, is it anything, what labels we apply to ourselves, where we focus our time. At the end of the day, it has to come back to what do your users need and how do you keep their trust in the reliability of your service. To do that, I recommend that you define a service level indicator and an objective for that to help you know whether you are achieving that or not. Once you've got that objective, you can turn it into an error budget. And that error budget then allows you to reason about how to plan, how to take feedback from whether you're achieving the right balance, and how to communicate with different parts of the business about whether you are meeting that goal of trust for your users. And then risk analysis is a tool to allow you to optimize where you're spending your error budget and making sure that you are spending it on planned activities that help move you forward rather than unexpected outages and surprises. And the link there is to a spreadsheet template that you're all welcome to copy and use to apply that method of expected costs to your software today. So thank you very much. I hope that's interesting to you. I'd love to catch up with you in the coffee break now or lunch or after the conference today. Hear your feedback on this or any other comments, questions, or things that would be interesting to talk about. Slides are linked there, my email address or Twitter handle. Thank you very much.